Now, quadratic formula. We're going to start ax squared plus bx plus c is 0. And we're going to complete the square. Well, first thing you have to do when you're completing the square, solving by completing the square, is you need a lead coefficient of 1. I don't want a lead coefficient of a. So I'm going to divide both sides by a, which gets x squared plus b over a in front of the x plus a c over a equals 0. Okay, next step, completing the square. We get the constants over here by themselves. The variable here is x. The a, the b, and the c just stand for some constant. Next step, completing the square. We half the coefficient on the linear term, which gives me b over 2a. And then we square it, which is a b squared over a 4a squared. And that's what goes in the hole. Okay, over here on this side, I need a common denominator. On this side, I just created my perfect square. It's an x plus b over 2a, all squared. And then you just ask yourself, okay, what do I square to get this thing? Well, whatever that is either positive or negative, the square root of that thing. And most people don't like to leave with negatives, so I'm going to rearrange the numerator. So if I want to get x by itself, I'm going to bring this over. All right, here's the thing. I don't know what the square root of that is. But square root of 4a squared is a 2a. And I don't have to worry about putting an absolute value of 2a because I've got the plus or minus out front. Like it's going to be either or, so it's all right. And most people like that with a common denominator. And that is the quadratic formula if you start here. So this formula will solve for x in any quadratic. That's why it's called the quadratic formula. Remember, quadratic is when you have it's x squared, where a is the leading coefficient, b is the coefficient of linear term, c is the constant, but it has to be set equal to 0. All right, so a, b, c. So x is equal to the opposite of b plus or minus the square root of a b squared minus 4ac all over 2a. There's 9 plus 20. So x is either negative 3 plus or minus the square root of 29 all over 2. This one, before you can do the quadratic formula, you set it equal to 0. Opposite of b plus or minus the square root of b squared minus 4ac. ac, 3 times negative 10, that's negative 30. All over 2a, 2 times 3 is 6. 16 plus 120. That's what, 136. 136, what can I do with that? And make it 2 and the square root of 34 all over 6. But I can divide it, I can reduce it and get it to there. Okay. All right, this one. Before I did the quadratic formula, there's no way I would use those numbers because I can divide both sides by 4. And I'll be honest, there's no way that I would use the quadratic formula as a problem. What multiplies by 4 and adds by 4? 2 and 2. Okay, but if we were going to use the quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. 16 minus 16 is 0. Square root of 0 is 0. Oh, look, I got negative 2 that way. Okay. This one, you got to get it set equal to 0. It's just like factoring. You want it set equal to 0. So I got a 25x squared minus a 20x plus 4, 0. Okay. So x is equal to negative b. So 20 plus or minus the square root of b squared. Negative 20 squared is 400. minus 4ac. 25 times 4 is 100. All over 2a. So 2 times 25. 400 minus 400 is 0. I'm going to get 20 over 50, which is 2/5. Okay, now had I been paying attention, when I got right there, I'd have looked, ooh, there's a good chance that's a perfect square trinomial because I've got the front and back are both perfect squares. 10 and 10 do make 20, and then 5x minus 2 is 0. X is 2/5. Same answer. Okay, let's see what we got here. X is equal to negative b plus or minus the squared, b squared minus 4ac, all over 2a. Here's a 4 minus 20. There's a negative 16. That's 4i. And then remember, reals, imaginaries. Negative 2/10 is negative 1, or yeah, so they're right. Negative 2/10 is negative 1/5, plus or minus 4/10 is 2/5, and that part had an I on it. Okay, I know note-wise, I just went through that really fast. So don't worry, we're not going to go over it that fast in class. Which part of the quadratic formula tells us the types of numbers? Okay, so think about this. So we have, here's our types of numbers. All numbers we know are complex numbers. You take the imaginaries out, you got the reals. Reals are divided into rational and irrational. Then you can have integers, whole numbers, natural numbers. Okay, the part that really matters is, are you going to have real or imaginary numbers, and how many answers will there be? So if you just look at this part right here, that's where you decide if it's imaginary or not. Like if that ends up being a negative underneath it, it's an imaginary number. If it ends up being a 0 underneath it, then you don't plus or minus anything, so you just get the one answer. So it's like if you did negative b plus or minus the square root of 0 all over 2a. That's just going to be this. That means you're going to have one real root, because there's no way you get a negative under a radical because you got a 0 under. Okay, if you do this and you get a positive number to there, you're going to have two answers, and they're going to be real because you get a positive under square root. They're real. If you get a negative under there, so positive number, negative number, you're going to get two numbers because it's plus or minus, but they're going to be imaginary. So here's the I guess the part that matters. The square root part is what determines all this, but really it's even more specific than that. It's the part that's under the square root. It's that radicand, like whatever this was. So it's the b squared minus 4ac is what determines everything. We call that the discriminant. Okay? And if it's positive, it means something on the graph. Like all these quadratics, graph parabolas, if you get the discriminant's positive, it's going to have two x-intercepts because there's going to be a place where the whole thing was, when does this equal 0? X-intercepts is when the function equals 0. If you just get the one real, it's going to just touch the x-axis. If it doesn't have any real ones, it doesn't mean it's not a parabola. It just means it doesn't actually cross the x-axis. So this is the last part. The discriminant, just figure out what that is. That's the b squared minus 4ac, not with the square root, just what's under it. So first figure it out. So b squared minus 4ac. Okay, so the discriminant's negative 4. What that means is that when you did this quadratic formula, some number plus or minus the square root of negative 4 all over some number. There's going to be two answers because you're going to add and subtract something, and they're going to be imaginary. You're going to have two imaginary roots. Okay? The discriminant, b squared minus 4ac, Discriminant 0. Some number plus or minus the square root of 0 all over some number. Limit, that's not going to be there. No way you get imaginaries. There's one answer. That implies you get one real root. B squared minus 4ac. Discriminant's 4. Some number plus or minus the square root of 4 all over some number. Means you're going to have two answers because you got plus or minus something. They're going to be real. You get two real roots.